God dag og velkommen, jeg heter Jacob Lee, and we are going to be talking about controlling a LED with warm and cool temperatures with two potentiometers, one being for brightness and the other being for color temperature. So, this is going to be the Arduino method, just controlling it with a microcontroller. It is by far the easiest and probably the cheapest too. If you buy all your components in bulk, using multiple 555s, inverters, and logic gates might be cheaper, but I'm doing this first because, like I said, it is the most simple, and if you just buy electronics like a normal person, it will be cheaper as well. So we are going to use the, let's shrink my screen here. Okay, we are going to use the Pro Micro. It has analog inputs, which we need for the potentiometers, and it has PWM outputs, which we need to control the LED warm and cool brightness. So I just have this pin out pulled up right here. Just for reference, we're going to be using pin A8 and A9 for the potentiometers, and we are going to be using pin 5 and pin 6 for the PWM control. So let's minimize that. This is our program. I've already started a little bit here. Like I said, pin 5 and 6 is going to be our warm pin and our cool pin. You can use any pin you want as long as it's marked as PWM capable. And you don't have to use the Pro Micro. That's just the one I'm using. I've got a bunch of them, and I think I have one soldered up already, so with the headers. So it's just going to be easiest to use this one. The color potentiometer A8 and brightness potentiometer A9. Again, you can use any of the pins that have analog that you want. I just already had this one written out. We're going to initialize the pin modes. Color pot and bright pot are both inputs. And then the warm pin is the output, pin 5, and cool pin, which is pin 6, is another output. Right here, I just have two analog write commands at 0 and delay for 1 second, and that just makes sure that when you turn it on, it is set at 0 for a second. And then what we're going to do is this is going to be the loop that we use to continuously read the potentiometer and write our analog value. So the first thing we want to do is read our color potentiometer. So we're going to, let's see, Okay, so what we've done now is we have initialized our variables that we used. I just kind of initialize them as I program. That way I'm not initializing a bunch and then misspelling them later. I just initialize them as I go. But, so I'll just walk you through it. Warm value equals analog read color pot. What I'm doing there is just assigning the analog input from the color potentiometer to the variable warm value. That's going to be a 0 to 1023 value. That's just going to tell us how much warm we want compared to the cool color. Then next we read bright value, but we're going to map that from 0 to 1023 to 0 to 255. Now, the reason we're doing that just all in one step is because our PWM out signal has to be between 0 and 255. And so since we're analog reading from 0 to 1023, I just remap that in the same step to 0 to 255. And I'll explain that right here. Since we have to write from 0 to 255 for our warm and cool PWM signal, when I read or assign warm PWM, I'm reading that warm val and remapping it from 0 to 1023 to 0 to bright val. Bright val is already mapped between 0 and 255. So what that lets us do is the warm PWM value is getting remapped between 0 and the maximum brightness, which is already corrected for that 0 to 255. Actually, I just saw an easier way to do this. Instead of using warm val, we can just put that analog read right there. And we just made our code a little simpler. So the warm PWM reads the color potentiometer signal and it remaps it from 0 to bright val. Bright val is already mapped from 0 to 255, so we don't have to change the warm PWM at all. And then cool PWM will be the inverse of the warm from 0 to bright val. So if bright val is all the way up at 255 and we turn our color potentiometer all the way up so we have the maximum signal, the warm PWM is going to be mapped from 0 to 1023 to 0 to 255 because brightness is all the way up, and so we'll have the brightest, warmest color. Now if we turn the color potentiometer all the way down, so when it reads this value, the warm PWM is going to be mapped 0 to 1023 to 0 to 255, but that's going to be very close to 0, so our warm value will be very low, even though the brightness is all the way up. Given that our warm value is very low in that situation, and brightness is all the way up, bright val is going to be close to 255, and we're going to be subtracting a very small number from it. And so the cool PWM will be very high, and that will give you a very bright, very cool light. All this is adjusted to bright val, so if you turn that down, the proportion of the light will be, the color temperature will be the same, but your brightness will just decrease. So then you just write those PWM values to warm pin and cool pin, and it will output the appropriate color temperature using those two potentiometers. There are other things you can do to keep the color from stuttering. So the PWM values, or I'm sorry, the potentiometer values will vary a little bit just because they're divisions of like 1,000, and you're probably not using super expensive potentiometers, so there will be a little bit of jitter. If you want to avoid that, have it only update if the bright value or the color potentiometer, the bright pot or the color pot, has changed more than like 10 points. So if it just kind of jumps between, 512, 513, 509, that way it won't keep shifting your color a little bit and causing a flicker or something. And so it'll only update if you change it more than 10. Okay, so what I've done now is set up a variable called diff, short for difference. Initialize that up here, and it looks at previous brightness, or prev bright, which is, we'll just go ahead and, obviously that needs to be over 10 if it's going to go through the first time. So diff equals the absolute value of previous brightness minus an analog read of the bright potentiometer. And so it adds that to the absolute value of the previous color minus an analog read of the color potentiometer. So it gets what the current is, or I'm sorry, it subtracts what the last value was from the current, takes the absolute value, and then does that with color and gets the absolute value of that. It adds it together, and if both of those add up to something greater than 10, it will go ahead and go through this loop and update the values. So prev bright, prev color, minus all that. And so it'll go ahead and update the first time. I guess I don't need to do that because previous brightness and previous color both equals 0. Most likely that is going to be greater than 10 the first time it reads through that. So previous brightness is 0 minus the current analog read. And then previous color is going to be 0 minus the current analog read. Both of those are, if your potentiometers aren't both set to 0, are going to be greater than 10. And so it'll go through, update, and then after that, it won't hopefully jitter as much and will only change once you start turning the potentiometers. So that's cool for programming. Let's go ahead and wire up a circuit and test this. So I'm going to go over to my workbench now. All right, we're at the workbench a day or two later, but I've got my oscilloscope and my power supply here, and I'm going to wire up the Arduino with what you need to at least get the PWM output that's appropriate for controlling your color temperature. I was thinking about using transistors and different LED that actually had color temperature control on it, but it's going to vary so much depending on how you want to power your LED, the wattage of your LED, and just a lot of different things that will be different for your project. So I'm just going to focus on how to wire up the Arduino and get at least the appropriate signals. So to wire it up, we obviously have two potentiometers right here, and we're going to wire them up as a voltage splitter. So we're going to have to wire up our power supply. We're just going to use this rail right here as our power in, and then our voltage to the Arduino. I'm just putting it in raw. You can the raw pin, it can handle up to 9 volts, I think, on the off-brands. On the normal ones, I think it can handle up to 12. Do not quote me on that. Make sure you double-check yours. But these, I think, can handle up to 9, so we're going to use that. I'm only going to provide 5 because that's really all we need. I'm going to hook up the ground pin here. Let's see, got the ground input here. These leads I'm just going to attach to the DC power supply. Now, to wire up the potentiometers, what we're going to do is just wire them up as a regular voltage splitter. I thought I had the leads already out, but this whole mess of leads. And like I said, we're just going to wire them up as voltage splitters. So one side goes into voltage. Both of these. So got your voltage to pin 1, then your pin 3 to ground. Just how you would normally wire up a potentiometer to give you an analog input. And you can use anything to get your analog input. You can just program the Arduino to cycle through color temperatures, and you don't even have to have an input, but you probably want an input. You want to be able to control it. So we're using pins 8 and 9, if you remember from the programming, for our color and brightness control. So those go in right there. And then our PWM out is pins 5 and 6. So we got that right there. And that right there. Okay, I don't think we need anything else. Oh, well, we do need to program the Arduino. And we have to plug in the oscilloscope and the power supply. We need another lead just to clip the oscilloscope 2 to ground. And then it will read the PWM out from these. And so this is just going to be to show you that the PWM, or I'm sorry, that the Arduino is outputting the proper PWM signal. One signal we'll see on channel 1 would be for cool, and the other signal would be for warm. I'll separate them and show them both to you, and I'll zoom in on this here so you can see it better. But I'm going to program this Arduino first, so I gotta unplug these. Again, I don't know why I did that already. Okay, be right back. Okay, so hopefully that uploaded properly. So let's make sure we get 5 volts out of our power supply before we hook it up. We wouldn't want to burn out our board before we even start. Alright, now we're going to turn this bad boy on. We should be getting a signal. Might have to adjust it first. Oh, there we go. Boom. Alright, now we're getting our channel 2. Alright, so you see this is from pin 6, this one's from pin 5 right here. And now we're going to adjust the potentiometers. Okay, let's see if we can shrink down that signal. Okay, so slowing it down, it looks like that's the best we're going to get, but you can still see the signal from pin 6 and the signal from pin 5. Let me change the shutter speed on the iPhone and see if we can get a better picture. Okay, now I'm filming in 60 frames per second. Hopefully we don't get that weird fade in and out. But so we've got pin 6, pin 5, PWM signal. Let's adjust the left potentiometer. I don't remember which one that one's supposed to. Okay, so that looks like it's adjusting brightness because it's adjusting both of the signals. The proportion is the same. Now let's try the right one. Okay, so this is your color adjustment. So you see this one on the bottom is either your warm or cool, and the one on the top is the converse. So if this one's warm, this one's cool. You can see when you turn, we'll say this one's warm. When you turn warm up, the cool goes down. It's going to be whichever one is on top is your high signal. Let's move this farther away. So this one down here, the line on top is your high. Right here, the one on top is high. And when you turn one of these potentiometers, it's going to be almost completely full on the warm and 0 on cool. Turn all the way the other way, and it's almost completely cool and almost no warm. Now you see that there still is some, it's not on all the way, so that'll probably be our brightness. Once we adjust the brightness all the way to one side, that disappears. So now you're on full brightness. You get full cool, no warm. Now let's swap it to show a little more warmth. And so you see the on signal for the warm starts growing and the on signal for the cool starts shrinking. So now you're about 50% each. Now you're going to keep turning it warm, keep turning it warm. So now you can see it's almost completely warm, almost no cool. You keep turning it, the cool disappears, and it's completely warm. Now you turn the brightness down. It shouldn't turn the cool on at all. It should keep your warm on, but it will decrease the PWM for the warm. So brightness on all the way, the warm is on all the way. Turning your brightness down will decrease the signal of the warm. And there you go. So let's put brightness all the way up again. Now we're going to try to get our temperature halfway between them. So we want each one to be on about 50% of the time. That's pretty close right there. And so that now when we adjust brightness, both of them should decrease or increase at the same rate. Okay, so now we're turning our brightness all the way down, and we just get like, 5% brightness. Now we turn it up, and it both increases to 50% each. Now, that brings up an interesting problem. When you turn brightness all the way up, and you want your temperature halfway between the two, you only get 50% of each color. That is because you just set it up to go in between each one equally. There is a way to optimize the brightness, so when you're at 50% warm, 50% cool, it will increase both of them to 100%, because that way you still get half and half proportionally. One is at 100, or warm is at 100%, and cool is at 100%. So that's halfway between warm and cool, because you get equal parts of both. That requires setting up a little bit more of a complicated function, and there's a lot of different ways to do that. Basically, if you've taken algebra, it's what's called a piecewise function. If you're below 50% cool or above 50% warm, warm is going to stay on 100%. And then you're just going to adjust the ratio of cool, or the power of the cool, to fit the appropriate color temperature. If cool is above 50%, it's just going to stay on, or proportionally, the cool LED power will stay on at 100%, and you'll just adjust the warm to compensate for the cool being on at 100%. That's a whole nother issue. I can go into it if you'd like. Let me know if you want to go into the theory of that a little more. But this is, I think, the best you do if you use the 555 timers, the AND gates, and the inverters, because you can't really set up a piecewise function. Well, I'm sure you could. I don't know how to set up a piecewise function right now using only logic gates. But I'm sure there's a way to do it. But if I'm being honest, I don't want to get into it. So this is the best way to do it. You can set up a piecewise function in the Arduino code. Like I said, if you want me to go into that, let me know. But that is how you control a color tunable LED with an Arduino and 2 potentiometers. So thank you for watching. I hope this was helpful. Comment if you have any questions. Subscribe if you want to see more. And let's see. What do I need to say? Oh yeah. Be sure to be nice to someone today. And I will see you next time. Peace.